Well, thank you very much, Charlotte, for that introduction. I'm not sure I'm going to live up to all of that, but but anyways, good afternoon, ladies and gentlemen. I think it's safe to say that shipping is navigating in a very complex regulatory landscape. But I think what we're already learning today, and what you'll see from my presentation as well, is that the stars are aligning to put nuclear into that regulatory landscape. So, without any further ado, let's put this into context, shall we? We live in a very energy-hungry world, and it's only getting hungrier. According to the International Energy Agency, global energy demand in 2024 rose faster than the average rate over the past decade. What was driving that? It was mainly increased demand for electricity, and that electricity demand again comes from demand for cooling. The world is getting hotter. It's not going to get any cooler anytime soon, so that will continue to rise. Industry needs it. Electric vehicle use is growing. And data centers, of course, is growing, and that is also expected to continue to rise. So the only way is up when it comes to energy demand. I don't think that's going to slow down anytime soon. So why is that relevant for shipping? Well, traditionally, shipping has been able to rely on an abundant, relatively cheap energy-dense source of energy, heavy fuel oil, which is a residual product of the refining process. And you haven't had to compete with other sectors for that. Now, of course, because of decarbonization, that's not really going to be an option going forward. And in addition to that, you are going to have to compete for greenhouse gas-free energy with other sectors, including other modes of transport, like aviation and road transport, and industry for those carbon-free molecules. And there's absolutely certain that that's going to have a major impact on both availability and price of all types of fuel, including fuels for shipping. Right. So, decarbonization, is that mission impossible? We all know the challenge. We know that really, really well now, the IMO 2023 greenhouse gas strategy. But one thing that I've bolded in there is the WT well to wake. It's going to be well to wake. This is new for shipping. Now it's not just about regulating what's coming out of your stack. You have to look at the whole life cycle picture of the carbon emissions from well to wake. That is a game changer. What makes this look like an insurmountable challenge is just how very little non-fossil fuels has been used by shipping so far. If you look at this graph here, that's data from the most recent data collection system for the IMO. And you can see here, that is the only bit that is alternative fuels. There's a fair amount of liquefied natural gas, but that's also a fossil fuel. So I think it's fair to say that this so-called energy transition has only barely begun, and we're going to need some serious ramping up and acceleration to meet the greenhouse gas targets. Even making it worse is that little tiny sliver, 0.4%, some of those fuels include methanol, which has also been produced using fossil fuels, so that doesn't really help us either. I think if we had seen the 2024 data, that little sliver will grow a bit. There'll be more biofuels driven by EU regulations, for example. And if you included ships below 5,000 deadweight ton, it might grow more, but those are not the big emitters. So there we go. Growing requirements around the world for shore power. This is an additional strain on clean energy demand. Now, shore power requirements are driven not by decarbonization, they're driven by clean air concerns, because ships in ports can emit some pretty nasty fumes, sulfur oxide, particulate matter, nitrous oxide, etc. But of course, those ports are also supposed to decarbonize. And today, some infrastructure is available already. How this is going to happen when, for example, from 2030, you have the EU regulations coming in to require shore power for a number of types of ships. The strain on the grid is just incredible. And to take an example from a UK port, Southampton, they have 2 cruise ship berths, which has capacity to shore to cold iron a cruise ship. And of course, a cruise ship has a pretty big energy need, but they can only use one at a time, because when they shore power one cruise ship, that doubles the energy need for that port, and they just can't deal with two at the same time. So, yeah. And of course, energy efficiency going forward is going to become more and more important, because you are going to have to use high cost, low energy density fuels, and you're going to have to pay penalties for emitting CO2. So energy, but it can only get us part of the way. We know that. Ships still need energy to move through water, keep the lights on, and keep passengers, crew, and cargo safe and well. So it can only lead us part of the way. So here, this graph, you'll recognize this as the official IMO 2023 greenhouse gas strategy, with the checkpoints in 2030 and 2040 leading to net zero. And there's also a sort of a low level and a high level of emission reductions, with the higher one, with the lower one being sort of what we strive for, and this being what we minimum have to do. And of course, in October this year, the Marine Environment Protection Committee, MEPC, is due to adopt the IMO Net Zero Framework as a revised MARPOL Annex 6, 2025. And that is trying to find a mechanism to enforce this to happen. It isn't perfectly aligned with this right now, but I'm just demonstrating here what it is trying to do. So for the first 2 years, we now know the figures for 2022, that if you're emitting above the level, you're going to have to pay $380 per ton of CO2. If you are sort of in that mid-range where you're between the tier 1 and tier 2, you need to pay $100. If you are emitting less, then you can earn remedial units. What are they going to be worth? Well, that is up to the market, because you can sell them to the people up here. So you could sell them of upwards to $380 per ton, but I don't think you can sell any more than that. And then we have another unknown down here, which is the zero or net zero rewards. They haven't quite decided yet what qualifies as a net zero fuel, so that's something we're waiting for. And we're also waiting for a price for this, because we don't know that yet. But we should know by 2027, March 2027. And then from 2028, that will be enforced. And of course, that's just the prices for the first 2 years. And they have to decide then from 2030 onwards what the prices will be, and they could be higher. So nuclear-powered ships are definitely going to unlock both regulatory compliance and competitive advantages, because with a nuclear reactor, you have on board an abundant, emission-free energy source, requiring no more space on your ship than the traditional diesel engine. So that ticks a lot of boxes, especially with the regulations. You can operate with absolutely no emissions to air or sea, which means no nasty local air pollutants, and no CO2 emissions. So you will be able to earn surplus units that you can sell, and you will also be eligible for ZNZ rewards. And an added bonus, I think, that we haven't really spoken about much, is that you don't have to worry about IMO energy efficiency regulations anymore. Perhaps, because what are they for? They are to reduce CO2 emissions per unit of cargo transported. So going forward, you can sail further and faster without any CO2 penalties. So that's perhaps a new chapter. And in terms of more efficient operations and competitive advantage, you've heard a lot about that already. But I think certainly one of the key points is that you have no uncertainty about fuel availability, because your fuel is on board your ship. And you don't need to have uncertainty about fuel prices either, because you can operate for years without refueling. You wouldn't have to plug into shore power either, which is not going to be free. And perhaps in the future, you'll be able to reverse cold iron as well. And most importantly of all, which you've heard a few times, with no need for fuel tanks and faster sailing speeds, everyone else is slow steaming to conserve fuel and save and avoid CO2 penalties. These ships will be able to transport more cargo in a year than any other ship, conventionally fueled ships. The existing marine nuclear applications, you've seen a bit about that already. So all of those have to date been using low light water reactor technology, which is very similar to naval reactors. And it works, we know it works, but they're not really suitable for civil purposes, as Chris Wanico just explained to you. And so far, all of these assets have actually been operated by national governments. And there's a very good reason for that, because national governments can underwrite these assets. They are not commercially insurable. And so we need a different solution which can be commercially insured. And moving on to the EPZs that we talked about, this really demonstrates it rather well. Imagine if that was your EPZ because of the pressurized nature of your reactor. Or it could be wider than that. And then you, of course, you have a problem moving up narrow seaways into port environments and maybe through a canal. Somebody could be walking their dog along that. So, and it's a mobile emergency planning zone, which makes it very, very tricky, not easy to insure. Also, of course, the state can underwrite it, but privately, no. So then when we move to having that emergency zone within the ship, suddenly it becomes available. And it should become commercially insurable as well. So in terms of regulations, we do actually have regulations already. We have the IMO SOLAS Chapter 8 for nuclear ships, which is actually a very short piece of regulation. It's very high level. You could probably fit all that into 2 pages if you use a small font. And it's very focused on avoiding radiation. But more importantly, we have the Code of Safety for Nuclear-Powered Ships, which was adopted as Assembly Resolution A491 in 1981. And that gives you a lot more detail about how to design, construct, operate, and eventually commission these ships. Unfortunately, that regulation isn't suitable for today because it's outdated and it's completely based on the kind of technology that was around then, i.e. pressurized light water reactors and the direct steam propulsion system. So it's not fit for purpose today. On the right-hand side, one more thing. In terms of that code, it also needs to be updated to reflect the most recent International Atomic Energy Agency standards, IAEA, because that's also out of date now. If we look on the right-hand side of this slide, this document is even older. It was published in 1968. It was a joint IMO-IAEA document, and it was helping to give some guidance on the considerations, as the title suggests. So I'm not going to go into detail on that. Unfortunately, it's so outdated that it has a line across here that says, this is no longer valid. So how is that going to help us? It's not going to help us at all, is it? So far, we've looked at the reasoning for all of this, which is what the MEPC has decided. But of course, SOLAS lives on the Maritime Safety Committee. And there's been some very important developments there. Starting at MSC 107 in 2023, when they approved a new work output with a snappy title, Development of a Safety Regulatory Framework to Support the Reduction of Greenhouse Gas Emissions from Ships Using New Technologies and Alternative Fuels. Does exactly what it says on the tin. We call it GHG Safety for short. And that was really well received. And work started immediately after that in the correspondence group, so that when we came to MSC 108, we already had correspondence group results to look at, and a very important document containing a gap analysis of the nuclear code was submitted to that meeting, also really well received. There was some work going on during that meeting, and then they re-established a correspondence group to continue this work, looking at the barriers and gaps in IMO instruments. And this is everything, not just nuclear, but nuclear is in the mix. At MSC 109, there was a little bit less work going on, but it continued. And then finally, green light, MSC 110. It formally approved a proposal to revise the nuclear code and set instructions for a subcommittee, the SDC subcommittee, that's ship design and construction, to begin the work at its next session. So at SDC 12 in January this year, next year even, that revision work will begin in earnest. Now, it's going to take a little bit of time, but it's starting, and that is, as Charlotte said, we are going to try to bring solutions in order to help bring that work forward. And when I say we, I'll get to that in a minute, but there's that pesky insurance question. Now, if a ship is facing unlimited liability, that's impossible to insure. We all know that, and that doesn't account just for nuclear. That's for any number of things. And there are several conventions in place for terrestrial nuclear, but we don't have one for maritime nuclear. There was one that they tried to do in the Brussels Conventions was negotiated in 1962, but it was never ratified because 2 countries couldn't agree on whether or not to include military ships. So that was meant for nuclear ships, but it never came to be. So there is still some work to be done here. And on that note, let's talk about NEMO for a little bit. So clearly, there's a lot of work ahead of us to achieve a fit for purpose in the regulatory regime for nuclear ships at the IMO. And we need input from the IAEA for safety, security, and safeguards. And we need to make sure that we have the right parties putting this forward. So that's where NEMO is coming into play. It's a new industry association for all stakeholders around floating nuclear power plants and nuclear ships. And with an the aim is to establish a harmonized regulatory framework that allows for a floating nuclear demonstration by 2030. It's quite an ambitious date, but that is the target. And I'm pleased to tell you again that both NEMO has achieved NGO status at both the IMO and the IAEA, so we are able to work directly with those 2 key UN organizations. And in addition, you've heard mentioned of the ATLAS project. This is from the IAEA, Atomic Technology License for Applications at Sea. It was set in motion by Director Grossi himself in August 2024 and aims to establish a robust framework for secure deployment of peaceful civil nuclear applications at sea, FNPPs and ships. Official launch is now probably going to be early 2026. And participants are going to include IAEA people, IMO people, NEMO, and Classification Society, of course, and national and nuclear maritime authorities. How am I doing, Tom? I'm good. Okay. So in the future, the IAEA will have efforts to analyze, review, and refresh existing standards and guidelines critical to enabling civil maritime nuclear applications. And it's really, really good to see the IAEA taking an interest in this, because the IAEA has been traditionally focused on everything land-based, but they are really on board with making this happen in the maritime sector. So in terms of creating then the conditions for civil nuclear ships, this is how we see it happening. And again, maybe a bit optimistic, but you have to believe that it can be done. Of course, in the first blue bit here, so that's already happened. The IMO has agreed to review the nuclear code as a good starting point, and to do that in dialogue with the IAEA, because we are going to need their input for this. And the IAEA is well on the way with standards for floating nuclear, in particular FNPPs. And the ATLAS initiative will continue to develop. In the middle here is the insurance bit, which brings in yet another organization, CMI, Comité Maritime International, I think it's a French name. And hopefully with their help, we will lay the foundations for a liability convention in due course. Exactly, maybe we will see that before the end of the decade. And then we move into green light territory. Late in this decade, towards 2030, the first demonstration project, probably FNPPs, potentially some domestic nuclear shipping. Of course, the Russians are already doing that in the Arctic, but that's state supported still. And then from 2030 onwards, you see delivery of fit for purpose technology deployed at sea. So that's where it begins. So to summarize all of this, in building the market for civil nuclear ships, of course, the first thing you have to do is to design and build according to IMO and IAEA standards. And that is really the reason why it's so important for that nuclear code to be updated, because that is what shipbuilders will look to clearly understand what is expected, what the standards will be. And of course, the IAEA's 3 S's, the safety, security, and safeguards, needs to be taken into account in that whole process. So that's the first step. Next is the licensing bit, which you've already heard a little bit about today. Of course, any ship needs to be approved by class. We know that. That's what we're used to. But now the ship is suddenly a nuclear site and it has a nuclear reactor on board. So for that nuclear reactor and to assess the viability of the site, you are going to need the nuclear regulators to be involved in that as well. And that's why we think it's likely, like we heard Chris say earlier, that the first nuclear ships will likely be flagged and licensed in countries which have well-established nuclear and maritime authorities that we are trusting. One thing that we haven't mentioned yet is that the flag state is essentially where the territory of the nuclear ship. So the flag state must continue to adhere to mandatory IAEA safeguards protocol. And that will probably make reflagging a nuclear ship a little bit more arduous than what happens today. And as you heard, the initial routes probably between specific countries and ports in these nuclear corridors because of the extra care and attention that is given to this. And ports do actually have a lot of power in denying ships access. And that's not just nuclear ships, that's any kind of ships that they don't really want to welcome into their ports. So we think the market will build gradually, building a license of trust with the public. These ships will be built and operated to the highest possible safety standards. They'll be great places to work, by the way, so it will be a really good way to entice new talent into maritime, which is something that the shipping industry is really struggling with today. And so finally, with time, nuclear-powered ships will become normal. Everybody sees this is working really well. It's not dangerous. Nothing bad is happening. So we are normalizing nuclear. And there you have it. That's what's happening in time. Thank you.